Hey guys, for this example, we need to locate the centroid and calculate moment of inertia. Okay, let's focus on how to locate the centroid. First step, I'm gonna divide this cross-section to different parts, probably rectangular part, circular part, or right angle triangle part. Actually, I will divide it to 3 rectangular parts. Part number 1 with this centroid, part number 2 with this centroid, and part number 3 with this centroid. I will assume we have a reference at the bottom edge. We have another reference, vertical reference at the farthest edge, like this. Let's start. I'm gonna construct a table. First column in this table, number of parts, number 1, number 2, and part number 3. Second column, what is the area of each part? I believe the area of part number 1 is 6 millimeter times 48 millimeter will be 288. Part number 2, the area will be 8 times 48 will be 384. Part number 3, the area will be 24 times 6, it will be 144. Third column will be what is the horizontal distance of each part relative to the vertical reference. Let's start. Part number 1, what is the horizontal distance between the centroid of this part and the vertical reference? What is this distance? It will be 24. Part number 2, what is the horizontal distance of the centroid of this part and the vertical reference? 24. Part number 3, what is the horizontal distance between the centroid of this part and the vertical reference? 24. Can you multiply area times x bar to figure out this column? So 288 times 24, it will be 6,912. 384 times 24, 9,216. 144 times 24, 3,456. Can you get the summation for this column? You can get summation area. Summation area times x will be the summation of this column. So the last column, summation of the last column will be 19,584. Summation of this area, of these areas, 816. Keep walking. We need to add another 2 columns. This column will be y bar and then area times y bar. Y means vertical distance. What is the vertical distance between this centroid of part number 1 and the horizontal reference? 3 millimeter. What is the vertical distance between centroid of part number 2 and the horizontal reference? I believe it will be 30 millimeter. What is the vertical distance between the centroid of part number 3 and the horizontal reference? It will be 6 plus 24 plus 24 plus 3, 57. Go ahead and multiply this column by this column. So 288 times 3, 864. 384 times 30, 11,520. 144 times 57, 8,208. Go ahead and get summation for this column, which is summation of area Y bar. Summation of this column will be 20,592. To locate your centroid, X bar for the centroid will be summation area X bar divide area. Summation area time X bar 19,584 divide summation of area 816. This value will be 24. That makes sense for me. Y bar for the centroid of this cross section will be summation area Y bar divide summation area. This expression will be 20,592 divide summation area 816. $25.2. So if you would like to clean up everything here, we have this centroid and this centroid and this centroid for each part. I will walk from this origin for the assumed reference. I will move horizontally a distance equal 24. And then I will move vertically a distance equal 25.2. So probably something here. This point can be called centroid for the whole cross section. At this point, I can put X and Y for the cross section. This vertical distance, how much? 25.2. And this horizontal distance, if you would like, how much? Will be 24 millimeter. Okay, this is the first part of this problem. Locate the centroid. At this centroid, I can put the X and Y axis. Second part of this problem, we need to calculate the moment of inertia about X axis and Y axis. So I will start with moment of inertia about X axis, Ix. I need to set up a new table. First column, number of parts. Part number 1, part number 2, part number 3. Can you remind me what was the area of each part? 288, I think. 384. 144. What is the value of Ix for each part? Let's start. First part is here. We have, or I will assume I have X axis here. For this part only. What is the moment of inertia about this assumed X axis for this part will be parallel time perpendicular cube over 12. So it will be 48 times 6 cube over 12. This value will be 864. Second part. we have another part here. At the centroid of this part, I will assume x-axis for this part only. Parallel to this part will be 8, perpendicular cube will be 48. So 8 times 48 cube over 12. This value will be 73,728. Part number 4. Part number 3. I will assume x-axis here. So parallel to this axis will be 24 times 6 cube over 12. 24 times 6 cube divide 12 will be 432. By the way, go ahead and get the summation of this column. It will be 75,024. What is the distance for each part? I'm sorry, what you mean by distance? Okay. For part number 1, I assumed x-axis here. But actually, the real x-axis for the whole cross section is here. What is the distance in between? What is the distance between this one and the actual one? I believe this distance will be 25.2, but you need to subtract 3. The 3 can be subtracted from this 25.2. You can get this distance for part number 1. It will be 22.2. What is the distance for part number 2? What you mean? Part number 2, I assumed at this centroid, we have x-axis for this part only. But we have a real x-axis for the whole cross-section. Can you tell me what is the distance in between? Yeah, the vertical total distance is 30 minus 25.2 . This little distance will be 4.8. Okay, guys, one more time what I did here. The vertical distance between this centroid and the bottom, 30. The vertical distance between the actual x-axis and the bottom, 25.2. If you subtract these two numbers, you can get the little distance here. What is the distance between the assumed x-axis here and the actual x-axis? What is the vertical distance here? I think this vertical distance will be 48 plus 6 plus 3 minus 25.2. It will be 31.8. Go ahead and find area, this column, times d square, this column square. And then find the summation. So this part is summation area d square. So 288 times 22.2 square. This number will be 0.9. Second one, 384 times 4.8 square will be 8,847.4. 144 times 31.8 square. This one will be this number. 145,618. Go ahead and get the summation for this column. the total will be 296,403. That means Ix for the whole cross section will be summation Ix, this column, plus summation area D square, this column. So the final answer will be 75,024 plus 296,403.9. The final answer for Ix will be 371,427.86 millimeter to power 4. To figure out the value of Iy, I need to set up the same table, but related to axis Y. How many parts? Part number 1, part number 2, part number 3. What is the area of each part? 288, 384, 144. What is the value of Iy for each part? So please forget what you did for each part. I will assume for part number 1, we have here y-axis at this centroid. So parallel to y will be 6 times 48 cube over 12. 6 times 48 cube over 12. This value will be 5,000 or 55,296. Part number 2, I will assume, I'm sorry, at this centroid, y-axis is here for this part. So parallel to y will be 48 times 8 cube over 12. 2048. Part number 3, at this centroid, I will assume y-axis is here. So parallel to this y will be 6 times 24 cube over 12. This value 6,912. Okay, go ahead and get the summation. This summation will be summation Iy. It will be 64,256. Go ahead and get the distance D. What you mean by distance D? Okay. For part number 1, I assumed for this part only, we have here y-axis at this centroid. But actually, we have y-axis for the whole cross-section at this location. Do you think we have distance in between? Both of them at the same line. For part number 1, for part number 2, for part number 3. So we don't have distance, we don't have distance, we don't have distance. Go ahead and multiply this column by the square of this column, area times D square. We will get 0, 0, 0. Go ahead and get summation area D square. You can get 0. So finally, Iy equals summation Iy plus summation area D square. Your value will be 64,256 plus 0 will be finally 64,256 millimeter to power 4. So guys, to finish up this kind of problem, we need to set up 3 tables. The first one to locate the centroid. The second one to calculate the value or the moment of inertia about x. The third one to figure out the value of Iy. One more example. We have another example here. T section looks like T section, and we need to locate the centroid. Let's start with the first one. To locate the centroid, I'm gonna divide this cross section to two parts. The first one, part number 1, with the centroid. For part number 2, with the centroid. I will assume my reference at the lowest edge and at the farthest left edge. Reference number 1, reference number 2. Then I will set up a table for centroid. Number of parts. We have part number 1 and part number 2. What is the area of each part? Part number 1, we have 3 times 12 will be 36. Part number 2, we have 2 times 16, it will be 32. What is the horizontal distance? For part number 1, what you mean by horizontal distance? I mean, what is the horizontal distance between the centroid of part number 1 and the assumed reference? It will be 8. What is the horizontal distance between centroid of part number 2 and the assumed reference? Will be 8. Go ahead and multiply area times x bar. 36 times 8, 288. 32 times 8, 256. Summation of area, how much? Summation of area x bar equal how much? So this column will be 544. This column will be 68. I'm gonna put another 2 columns. The first one, what is the y bar? What you mean by y bar? Okay. What is the vertical distance between centroid of part number 1 and the assumed reference? It should be 6. What is the vertical distance between centroid of part number 2 and the assumed reference? It should be 13. Go ahead and multiply this column by this column. So 36 times 6, 216. 32 times 13, 416. Go ahead and get the summation here. Summation area y bar. It will be 632. Finally, I can figure out centroid. X bar for the centroid equals summation area x bar divide summation area. 544 divide 68. How much? 8 inch. Y bar equals summation area y bar divide summation area equal 632 divide 68. This number will be 9.3. I will clean up. So guys, from the origin of the assumed reference, I will move horizontally distance equal 8, and I'm gonna move vertically distance equal 9.3. This point will be the centroid for the whole cross section. I can assume the actual x-axis here and the actual y-axis here at the centroid of the whole cross section. Just for your information, this vertical distance, how much? 9.3 vertical distance to locate this centroid. First part, locate the centroid to put x-axis and y-axis. Second part, I'm looking for ix. So I need to set up another table. Part number 1, number 2, What is the value of area of each part? 36, 32. What is the value of Ix for each part? Okay. For part number 1, I will assume I have x-axis here at the centroid of part number 1. Parallel to x will be 3, perpendicular to x will be 12 cube. So 3 times 12 cube over 12. This value will be 432. Part number 2, I will assume x-axis is here, so parallel to x will be 16 times 2 cube divide 12. 16 times 2 cube divide 12. It will be 10.67. What is the distance d? What you mean by distance d? I mean, for part number 1, you assumed x-axis is here, but actually the actual x-axis for the whole cross-section is here. What is the distance in between? This distance can be 9.3 minus 6. 9.3 is the vertical distance between the actual x-axis and the horizontal reference. This distance was 6, half of 12. If you subtract both of them, you can figure out the value of the distance, 3.3. Part number 2, you assumed x-axis is here, but actually the actual x-axis is there. So we have distance in between. What is this distance? Will be 13 minus 9.3 equal 3.7. By the way, the distance between this one, the assumed x-axis, and down is 13. And this distance is 9.3. If you subtract both of them, you can figure out this distance. We need to add another table, another column, area d square. This column times this column square. So 36 times 3.3 square, 392. 32 times 3.7 square, 438. Summation of this column, summation Ix, summation of this column, summation area d square. This one will be 830. This one will be 432 plus 442.67. So the final value for Ix will be this value plus this value. The final value will be 1272.67 inch to power 4. Third column for Iy. We need to set up a new table. Part number 1, number 2. What is the area? 36, 32. What is the value of Iy? Guys, for part number 1, I have y-axis is here at this centroid of part number 1. So parallel to y will be 12 times 3 cube over 12. This value will be 27. Part number 2, I have y-axis is here at this centroid, so parallel to y will be 2 times 16 cube over 12. This value will be 682.67. What is the distance d? I think we don't have distance between this y and the actual y-axis. Actually, for part number 1 and part number 2. So your distance will be 0 and 0. And the last column, area d square, will be 0 and 0. Summation here will be 0. Summation here will be 709.67. So finally, IY will be this value plus this value. So the final value will be 709.67 inch to power 4. So your answer should include 3 tables. The first one to locate the centroid, the second one to calculate IX, the third one to calculate IY. Finally, we have another properties or other properties, someone called polar moment of inertia. Polar moment of inertia will be used to figure out the effect of torsion. It's out the scope of this course, but by the way, if you add IX plus IY, I can get the polar moment of inertia. So for this example, the polar moment of inertia, which you called J equal IX plus IY, it will be this number, 1272.67, plus this number, 709.67. So the final value will be polar moment of inertia. Piece of cake. So the polar moment of inertia is another properties, but is used to check the effect of torsion. Okay? Effect of torsion. And the value of the polar moment of inertia equal the value of IX plus the value of IY. We have another property called radius of gyration to figure out the effect of buckling. We have something called R, small rx, small ry, small r equal square root of Ix divide area. We have area for the cross section. We have Ix. If you divide this value by this value and get the square root, I can figure out the radius of gyration about X. We have another radius of gyration about Y, but these properties only just for your information. We have something called polar moment of inertia to support torsion. We have radius of gyration to resist or support buckling of long members. Okay, but in this course, we need to focus only on how to locate the centroid and how to calculate the moment of inertia about x-axis and y-axis.